Okay, hi everyone. This is my fourth live stream of today, but energy persists. We are talking about chemistry functionality for version 13 of Wolfram Language, and the first function we are supposed to look at is what?
Find isomers.
Is this an agenda for? Oh, is this? I see. Find isomers is up there. See, by the way, Brady, a practical point. It'd be really good if that could be a link that actually pulls up.
This isn't my agenda, but
I know it's not your agenda.
Well, I actually tried that. I made a link in DocuTools and then copied it back out into the other notebook. But because of the style sheet, it didn't go to the DocuTools version. It tried to open up the documentation center.
Oh, right. you can use the dot. I can. Okay.
So if there's a way to do that, I'll figure.
Yeah, okay. There is. I'll tell you.
And you should tell every other person who's setting up design review meetings as well, Brady.
Okay.
Okay, find isomers. Beautiful. So for example, if I say,
these are the chemical isomers, right? Not the nuclear ones.
Correct. So you'll want to wrap that in molecule.
That's not an adequate result.
Correct.
Why do I need to wrap it in molecule?
Oh, I guess you don't. But apparently that I haven't tested that before, and I check it to see if it's a name before I check it to see if it's a smiles, and so I need to fix that. You shouldn't see that error, is what I mean to say.
What's that about? Should work with a list of molecules. Why not?
What should it do? How should they be represented?
Well, I was just thinking it makes a list of plots.
But most plot functions take a list and give you one graphics.
Yeah. All right. Okay. Fair enough. Okay. I mean, it would be nice if that. Well, that's lovely. What are those?
So that represents stereochemistry. You're seeing the particular carbon that you're looking at is going back into the page.
Okay, so now let's say I want the graphs here. How would I get those?
So either do molecule graph on them, or I believe that Charles was working to make graph more omnivorous. I think that is the word I heard them use.
Well, actually, I'm going to just try doing this and see whether that works. Sigh. Why doesn't that work? I mean, it doesn't have any good reason not to work.
That is a reasonable suggestion. Right. Okay. So, and you mentioned this, and I haven't done it yet, that the molecule graph should construct a molecule or a graph with the vertex coordinates.
Yes.
But what occurred to me, I didn't think of this until after the meeting, the reason it doesn't do that is because that can take a non-zero amount of time. And sometimes you want the graph, you don't want to look at it, you just want to do computation. And actually, I mean, it takes me longer to lay out a molecule in 2D than it does a graph generally, because there's more things to consider.
Okay.
And so
I think it's useful. I think it's useful by default. Now, the question of whether well, at least molecule graph needs some kind of option or something.
Right, so it could take the vertex coordinates option, and it could by default, let's see, so.
Well, vertex coordinates are automatic. Might. What was that supposed to mean? I mean, that or inherited or something. I'm not convinced here. How long does it really take? I mean, it could take a long time for some complicated protein-like molecule or something.
For a large molecule, it could take tens of milliseconds, usually.
Give me a big molecule. Hemoglobin. Do we have that?
not in a good way to type. I usually make a biosequence if I want to make a big molecule, because that's the convenience.
That's pretty cool. But now why did it even, oh, wow.
So that's just graph laying it out there.
Wow. That's neat. That's a good example, by the way. Please send that to me for my examples collection.
Okay.
Okay, so Michael, what do you think here with respect to whether this should happen by I'm agreeing with you that happening by default doesn't seem to make sense. We just need a way
I
to
don't know
specify.
what people would most often do.
I
but-
would like to see the molecule plot coordinates on the graphs. That makes the most sense to me. You can relate directly to the chemistry at that point.
But then we should have an option like we have even
Right.
for down values,
Yeah.
like sort or not. It might be non-trivial amount of time for some applications.
So
Yeah.
what
Right,
if,
so then the thing to do would be in molecule graph, give a vertex coordinates option
Mhm.
and
automatic is molecule coordinates and then the string graph?
I don't think that's the right way to do it because I think
Okay.
we've already got vertex coordinates. What are the other settings right now for vertex coordinates?
So they can usually be a list of the strings.
What? How
the
could
different
this
types
not
of
be
embeddings.
found? Why is vertex coordinates not found?
Your front end seems to be disconnected from your documentation. That's my guess. Just because, or
I was going to say that I think the closest analog I can think of is what mesh connectivity graph does. By default, it can inherit the coordinates in a mesh, but you can also set the vertex coordinates to just use a generic layout.
How does it do that?
I forgot what Charles did for that particular part, but there's a way. By default, it inherits coordinates from the mesh it came from.
Annotation rules inherited. Okay, so we should probably find out how it does this. But I kind of think I'm kind of thinking that automatic means the usual vertex coordinates are automatic, and that vertex coordinates arrow inherited should pull in the one from the molecule. See what I'm
makes
saying?
sense.
And that the
Yeah.
default should be inherited, and that it's only for the more advanced users who want to make things run quickly that they use automatic.
Yeah, I can do that.
Okay. And we should find out the answer to this mesh connectivity graph question. Okay, lovely.
So one
right.
question about find isomers that I didn't put anything in the documentation, but I wonder how one might document this fact that if you have a function that is going to return 10,000 molecules and you do not end it with a semicolon, it can be very disruptive. Because through reasons I'm not quite sure of, it's not going to show you all of it because you have an output limiter, but it's still going to lay them all out. It's still going to
Oh,
format
that's
them
a
all.
bug.
Well, I think it's just the way that, well,
It's just
that
a
may be
bug.
true.
So
but,
nothing to document, just fix the
Okay.
bug. I mean, I don't understand what's generating all of them.
Well, no, I mean, so in general, if you return to the front end a list of anything, right? The way I understand it is it still calls and formats everything and then
Oh.
decides to do short and to elide that.
What are you talking about? Wait.
No,
You're
no,
talking about
I
the
think
case.
the reason is slightly different. The reason is that the output limit for some things that are formatted is still pretty high relative. Like if it would be a pure string, it would be no problem to show it. But if it's something that needs sufficient amount of formatting, it can still be a lot of work.
Just explain to me the case we're talking about. I mean, if I say find isomers of, let's say string join.
C10H18.
What's that?
C10H18 is enough. Why? Okay, I don't know why that's happening.
Okay.
Right, and so then at this point,
Okay, well, this is for the front end team. It's not for you. It's not for us.
okay,
So I mean, you've computed the structures, right?
correct.
Okay, so is it a transmission problem? How big are the structures?
They themselves aren't that big. It's
That is
calling
exactly the
make
problem.
boxes.
They are relatively small.
Right.
Okay.
So the structures themselves are much smaller than their boxes, I guess. Or I'm not. So I'll contact
exactly.
the front end team
Exactly.
and see
That
if,
is
this,
this,
if that is workable. Okay.
Something is wrong here, and it's not. Yeah. Okay, so you're telling me that if I were to do, and now I'm about to find out if you cache. Are you caching?
No.
Well, you should be, shouldn't you? Why not? Why not cache?
Let's see. So well, so that's always a question, right? So if you're always caching and someone is doing something in a loop, then they can point to that and say that's evidence of a memory leak, right?
That's a sub issue. I don't think that's an issue. I mean, I don't know whether this is the right thing to cache. Anybody else got an opinion about that?
I would say no.
All
The output can be large. I'll contact lkernel and see if that, yeah, that's my thought, is that the output can be quite large.
Okay. All right.
Especially
Okay.
for the computed ones, potentially.
Yes. Do we really get to see Cayley's n to the n-3 here? How would you? In other words, if I just say, what happens if I say here, what would happen if I just say C10? Does it hydrogenate automatically?
No, so it should find nothing. And in this case, there's a bug where it's going to return unevaluated. So no, so I guess PubChem has some entries like that.
Okay. That first one looks like something maybe from Magen, because it will give you the ring with all double bonds.
Weirdest allotropes of carbon you've ever seen.
Yep.
So I just want to, these Java errors that you're seeing, I'll need to contact Roger. So the packlet uninstall command up at the very top seems to have not removed that packlet from last time. And
what is that creature?
It's like a baby chick.
A what?
It looks like a baby chick.
Looks like
like
a
a 3D
micro buckyball.
Yes, something like this.
Okay, so how do I find out what it is?
So
You can plot 3D or not? Can you not?
So you could copy it and ask for the sub value PubChem compound ID, and that'll give you an external identifier with that'll link out. So someone made an entry in that for that.
PubChem compound ID.
Yes.
Why isn't this auto completing? There's something wrong with the autocompleter here. Should be. This is a literal case, right? It's a sub value of molecule. It knows it's a sub value.
I have not. I will set those up.
Okay.
So then the number is a hyperlink. Most likely somebody made that just in a computer program and submitted it. They were able to come up with a name for it, but I would guess that nobody has made that.
Oh, it looks like a Prismane.
I don't think they make Prismanes that small.
Well, somebody. Okay. I'm just wondering if this is a real thing or whether. Okay, who knows?
Generally, it doesn't have to have actually been synthesized to be.
No, I realize that. But okay, I mean, this looks like a very weird object. I'm just kind of wondering why we have it. And also, boy, there's some strange things here. Okay. Would this actually hang together?
No.
Very unlikely.
And not even the poly, maybe the polyacetylene, the one you've got highlighted, selected.
Yeah. Well, the polyacetylenes are commonly used as conducting plastic, so that might have a chance to be actually seen.
Yeah. And the last one, I think there's a nitrile variation of that. Instead of acetylenes, it would have nitrile groups.
Okay, just for my
Tetracyanide.
chemistry education, what is an acetylene?
I'm
Anything
sorry, I
with
didn't
triple
hear that.
bonds.
Is it what is an acetylene? Is it the three
A
bonds?
triple
one
bond. C
Triple
triple
bonds,
bond
yes.
C. And a nitrile is C triple bond N.
Sometimes called cyanide as well.
Oh, okay, I've heard of that. Why does my chemistry moment? Cyanide, doesn't cyanide bind the iron in the hemoglobin?
Yes, it
That's
does
how
bind.
it's toxic.
Yes, it binds the iron and hemoglobin if it's a cyanide anion. When it's a cyano group in an organic molecule, it's stable
Correct.
generally.
But otherwise, it just
Generally.
rips the iron out of the hemoglobin.
It keeps oxygen. It displaces oxygen and it binds much more tightly than oxygen does, and that's why it's poison.
I see.
Since the cyanide is sticking to the iron, oxygen cannot stick to the iron and hemoglobin, and we suffocate.
Right. Okay. Okay. I mean, but we're not horrified by this result. In fact, we are impressed by this result. Is that a true statement?
Yes.
I'm kind of surprised that they're actually in PubChem. Yes.
It's
The
nice.
first two look horrifying.
What the heck are these? I'm going to go spelunking this. What is that? What is that creature? Now I've just learned it's full of acetylenes.
It's a yeah. It's a cyclic polyacetylene.
Yes.
Can it be made?
It's really dubious, right? Because those they want to have 180-degree bond angles, like the one on the right there.
Well, yeah. I mean, this is laying it out with hexagonal geometry, but that ring is large enough. If you made an icosagon, I guess that's what it's called, a 20gon, and measured the internal angles, they would be distorted from 180 degrees, yes, but not greatly so.
So yeah.
And so in principle, something like that could be stable enough to put into a bottle.
Wow. Okay. One of these is a buckyball, presumably that one.
I think the second one.
So if I take that second one and I say, it's a pity that's a molecule plot. If I say this, I'm obviously.
So
no,
it would
it's
be the
an
first
anion
one.
actually. So it's the first one. I didn't notice the negative charge.
This is quite magnificent that we can do all of this.
I should really be calling to graph when laying out fullerenes. No, I mean, I'm serious. Like the
Yeah, well, but that's the spring electrical model is probably.
I don't recall ever seeing graph layout a fullerene like that before.
The spring electrical model is pretty good for laying out Goldberg polyhedra in general. So fullerenes easy.
Well, so it was my impression that graph would try and do a planar embedding on a fullerene.
No way.
Okay. I mean, it's a planar graph. So.
What's
Yeah,
a planar
technically
graph?
yes.
Not a
It
planar
is.
graph.
It can be embedded in the plane, but it's not the
Yeah.
best way to look at it.
No.
Right, and I mean, the automatic methods I have in the molecule package for laying out these fullerenes, it gives up and goes for the planar embedding.
So you're saying here, there's a bug in this. There's a bug here. Obviously, there's a bug there. Wow. This is very buggy. Please.
I will.
So you are ending up with that kind of embedding. Is that true?
Yes.
Okay. What are these guys? I mean, are these anything real, or are they just sort of somebody's drawing? What's that thing? Is that carbons?
Yeah, it would
It
be
is.
Yes. they
yeah,
should
a
be.
4-membered ring.
But you can't make that, can you?
4-membered, yeah, cyclobutane
You
is
can.
stable.
It's got a lot of ring strain.
Yes,
Right, if you want to
that's
make
the problem.
explosives, you like those small rings. I think.
3
Sorry?
or 4-membered
You
rings.
want to make what?
If you like me-
Explosives.
yeah.
3-membered or 4-membered rings. They're very easy to break and release a lot of energy.
Huh. Okay, well, I'm going to go spelunking. I want to find out what graphs you can make out of carbon. That seems like a good challenge for molecular computing and so on. Is okay. Let me stop getting distracted here. Okay, let's get back to business. What was the next thing here? Reaction balanced Q. So find isomers we're done with. Yeah.
Yeah.
What's form?
So what do you when it can be returned in a particular type?
Why don't you say graph? Why didn't you have graph as one of those as well? Why not?
Yeah. I can do that.
Okay. This is a nice function.
Thank
It's a
you.
very useful function. At least for me. Even if nobody, because I don't make actual chemicals, at least yet.
So we're working on another function that will generate isomer. I guess we would call it generate isomers. But there you really get into a combinatorial explosion.
Right.
That's for a different meeting.
I see. So there, I mean, in this case, if it isn't in PubChem, it doesn't exist. So if I take sort of find isomers of, just a random thing, like I say, find isomers, oops, that's not what I wanted. I said find isomers of C100.
Right, and that's going to return an empty list. The fact that it's returning unevaluated is a bug.
Okay. Something went wrong with my selection here. Okay, so you're saying if I'm just out of my curiosity. Wow. Whatever.
Right, so someone decided to kind of populate all the polyacetylenes that they could and submit them, is what it looks like.
Yeah.
What's that guy? I think we're going to find, if we look far enough, we're going to find some obscenity or something drawn out of a molecule in PubChem.
Perhaps.
Great. Okay. All right. Let's see. We were looking at chemical reaction, which right now
it's going to be very experimental for this first release. Chemical reaction is what represents an actual reaction with not a pattern, no templates.
right. So an example would be, boy, it's an obscure one already. Okay, so this one here. Why is it taking time to grind? What's it doing? What was it doing when it?
Probably converting each of those entities into molecules.
I see. Why is that slow? Why is that slow?
I'm not sure. It should not be. So,
But that returns a chemical reaction. But what happens if I want to get it in this form of a yeah? What happens if I want to get it in this form?
so I don't have a subvalue to return that. If you ask it for its reactant counts and its product counts, you can get either side of that.
And we get the whole thing though. Seems
Right, so
useful.
what would we? What's a should we,
Rules?
reaction rule?
Yeah, reaction.
Yeah, that
rules,
makes
okay.
sense.
Yeah.
Okay. And otherwise, okay. So balanced reaction, balanced Q. By the way, I notice in that autocomplete product match Q. Do you guys have any involvement with the reaction PDE stuff?
I think that's Oliver's.
It is all of us, yeah.
No, I mean, so I've looked over a couple of examples, like some really interesting ones he wrote about with catalytic converters and surfaces. I don't know if that's related to it at all.
Yeah, well, probably. But I mean, my question is this
I would love to make this into something that he can use.
right, but I just want to make sure that it's consistent. Reaction coefficient, blah. Worth just having a little look.
Yeah,
Whether it makes sense. Okay, let's look at template reaction, which is the main thing you want to talk about, right? Oh, molecule free Q, what the heck's that?
It's when I was just slipping in here. If we have molecule match Q and we have molecule contains Q, it's just a convenience function. That's essentially equivalent to not the negation of molecule contains Q.
So if I want to find out, does this contain a sulfur? I just say molecule free Q, blah, comma, S. Is that correct?
Yes.
So for example, I could take this molecule here.
Well, you did contains Q.
Oh, but it doesn't contain a sulfur.
Right. So it's.
Oh, I see.
Free.
So sorry.
Too many live streams.
Yeah.
Okay. Now, my question is about hydrogens. Okay, so if I say molecule CC, right, that implicitly has hydrogens. And now I say molecule free Q. Okay.
Right. And so we use hydrogen suppressed graphs when appropriate underneath the hood, but we try to make that into an implementation detail.
Okay. Why does that happen?
Let's see. So what you should do, I believe it should work. If you gave include hydrogens goes to explicit only as the option to molecule free Q. But essentially, I try the include hydrogens as an option to molecule. I try not to use or advertise, because our users find it confusing that having to worry about whether the molecule has implicit or explicit hydrogens. So it essentially, they're always there if you ask for them. And if there are cases where we can do things more efficiently without them, then I'll remove them.
I see. So this isn't. What I made was a molecule, even with include hydrogens to false.
It still represents
represents
ethane.
Really? So if I do, but you're saying, what is the case that you're saying here?
So molecule free Q of
No,
molecules.
molecule. Well, what happens if I say explicit? What is
only. And so give that as an option, not to molecule, but as an option, a molecule free Q.
So you're saying if I say CC is a smile string, there's no way with any include hydrogens, stuff that I can request the thing without the hydrogens.
So if you want just two connected carbon atoms, then the way to do that is in a smile string is to wrap them in hard brackets.
Okay, fine. So there's a smiley way to do it. And yeah, okay, fair enough.
This goes back to what we've talked about on and off a lot about hydrogens and whether or not a molecule, if it would normally have them, to have them in the representation, as opposed, and as opposed to something syntactic that's completely structural in Wolfram language, and whether or not they're there as what you've written. And most users, most uses of molecule expect the hydrogens to be there, in the representation.
Okay, fair enough. All right, reactions. Okay, we're just starting on reactions. So reactions are a complicated area. I very strongly believe that our whole multi-computation story of, how we represent essentially transformations that take multiple inputs and give multiple outputs is going to be the same story as reactions. In other words, let's imagine that what we've got is a list of expressions. Whatever it is, something like this. Then what I'm imagining is that it's a floating soup of expressions, and we will have transformations which say things like f of, I don't know what, f of blank, comma, g of f of a blank, comma, g of f of b blank or something. That whole thing goes to g of f, whatever it is. That transformation is basically the same kind of thing as these chemical reaction transformations. Although the chemical reaction case is closer to the graph transformation case. Do you agree, disagree, have a thought about this?
So it is definitely close to the graph transformation, like using kind of, it's basically like so it is your graph rewrite rules. And there's a convenient language used because the graphs here, they're vertex and edge labeled, and those labels matter so much. There's a convenient syntax, or people have adopted a notation for these types of transformations.
What do you mean?
So you can have, just like you can have smiles, you can have reaction smiles, reaction.
Right, where you have these numbered atoms and things.
Right. I will place one in the chat here. I would have thought that would. Okay, so just imagine that should have evaluated and worked, and but essentially, I mean, what you have there is you have the two angle brackets denoting the left and the right hand side of the transformation, and then you label the atoms with the mapping number, and then you have shorthand for types of bonds. And so in this case, you have two double bonds being converted into a single bond, I believe. So this is a hydrogenation reaction.
Which means nothing to me, but yeah.
Yeah, if that didn't evaluate, then I have fear that the other examples won't as well. But
can I see an example over here, or?
Right. So try taking off the word chemistry there. I wonder if maybe the extra packlet that's floating around. Yeah. Okay, so that's the issue.
So what happens if I say molecule plot of this?
So you would do a chemistry reaction plot, because I have not got that ready for system. So hover over the atoms. This is one of the neater parts about it.
That is neat. Although the ends of that double bond, aren't there two atoms there, and do they both go to the same place? No, that one is an obscure case, right? Which one is it? See what I'm saying? There are two atoms at the end of that double bond, but only one atom on that, single bond.
So so let's see. So there's
No.
two missing
The double
hydrogens
bond
there.
has just one carbon, and it's highlighting one carbon on each side.
Oh, yeah, right.
Yes.
Okay, you're right.
It's not that great. I sometimes wonder if for ethene, it wouldn't be better to adopt the all atom representation for the 2D like we do with water.
Well,
I think
molecule
some
plot
case
with
could be made for
ethylene
that.
would show it with the hydrogens also. But
Okay,
this is a reaction plot, which has more elision.
okay. That's pretty neat. Boy, this is so similar to what we're doing with other things. It's so similar.
Right, and so whatever. So what we have for now essentially follows the. Let's see. So it's compatible with the reaction, or let's see. I think the technical term for them is smirks, which so they came out with
Smirks.
smiles and then smarts and then now is smirks. Although to be honest, so Daylight is the company who wrote the standard for these types of line notations, but there is let's see, what am I saying now? It's up to everyone else to implement them, and so the rules that they specify for smirks are not universally applied. But it's right, so it's not terribly standardized, but it's a smirks is a way of writing a chemical reaction as a transformation object. And so we essentially have the longer form of template reaction would be a list of molecule patterns going to another list of molecule patterns, and also describing the patterns as atom patterns and bond patterns, but with the caveat that you number the atoms in some way.
Okay. Okay, let me see here. Okay, so what are we looking at here? What does reaction apply? Okay, so that's basically a bunch of rules.
So reaction apply takes the reaction as the first argument, and then a list of molecules as the second, and then spits back a list of products.
Why doesn't it take just one atom here? Those are multiple atoms which can occur in the reaction. This is a soup where you can pick out any subset from this. It's like subset replace. Is that correct?
Let's see. So,
Jason, is that one of my examples?
yes.
Yeah. Okay. So it was just using the same reaction and one of the same starting materials, but a different choice of starting material from that list, just to see what the different products would be one at a time.
How do we get all of the subsets here? Or maybe it's overlaps that are true. Oh, come on. How does one do this? No. That's crazy. How do I... Oh, I can obviously use another version. or I can just go to the web.
Right. So if I can, you mentioned, while you're looking at this, so you mentioned like kind of treating the second argument. So we have a reaction apply as taking the reaction and then a list of molecules. And the question of whether to treat that as a soup of molecules or to treat that as a list, an ordered list, which you then match against the ordered list of reactants in the molecule, is something that we have thrown around back and forth. And
I understand. You've got exactly the same problem as we've got in this general multi-computation area. It's the exact same set of problems.
Well,
Okay.
so it's, yeah.
So we should solve them all together rather than solving them concretely.
Which is why I'm not trying to rush reaction apply and template reaction in out in the next little bit.
I'm thinking about this. By the way, Volunteer on our live stream is asking, can you only number the significant atoms?
Let's see. So you if you don't number an atom, like, let's see. So yes. So you want to only include the significant atoms and you only want to number them. If you have an atom on one side or the other and it's not numbered, then it's not clear what to do with it. And so by default, it's disposed of.
But wait a minute. So are these supposed to be subgraph transformations?
Yes.
Yes.
That's another whole eye-rolling can of worms. Because sometimes you want that and sometimes you want, right, the whole molecule is consumed in the reaction. Right? And it only happens if it's the whole molecule being consumed. Isn't that right?
Well, let's see. So the pattern matches against part of the molecule, and then the whole molecule is transformed. Like you're.
I understand that. I understand that. But there are some patterns which I would think you would want that are only whole molecule transformations.
Right. Okay. So then.
Yeah, that's kind of like including start of string, end of string on the string pattern.
Yeah, that's a good analogy. Yes.
So we need something like that, a wrapper that says,
okay,
but
this guys,
is the whole molecule.
We are in the process of inventing something which does this for general pattern matching. We should use that technology.
Yeah.
So again, what is the non-smirky form of this reaction?
Let's see. So if you open up the polymerization of amino acids, they're a little larger, but they're laid out in full form.
Bluff. We surely should have a more programmatic version of n:5, like n list n,5 or something.
Right. So actually, yeah, that could work. What also works is atom n, comma, atom map number goes to 5, but I got tired of typing that out as much, and so I defaulted to this. But they both work.
But the substring, the string, n,5, does that work?
No. So I thought you meant like atom first argument n, comma, list n,5.
Yeah, that's what I'm suggesting. Yes.
Yeah, it does not work, but that is preferable to me over atom map number goes to.
I mean, it would translate to the latter, right, Jason?
Well,
or would you allow the first element of an atom to be a list of an atomic symbol and a mapping number?
So I think the latter, right?
That might lead to confusion where people who are not doing reactions might think that means some kind of isotope number or something like that.
Yeah.
Sorry, which was this? What?
If you said atom open bracket open list quote C quote comma 13 close list close bracket, because it's the 13th atom, somebody might think you mean carbon 13 instead.
Right. Well, it might be better to have something like atom. Again, let's find out what we're going to do for other purposes, but something like this.
Yeah. I was thinking
Or
the
alternatively-
other day about this stuff along with the multi-computation and the graph rewriting. And then the graph rewriting for the physics project, there you're writing your graphs. You've already got all the vertices labeled, as it were, and the rewrite patterns do as well. And when I had trouble I had with that in the past to do it for chemistry was trying to say that a given vertex was a carbon or an oxygen. There was no way I could make that specification. And on the chemistry side, we're just the other way around. We label everything with the atomic symbols. And now all the vertices, quote, they look the same. And we have to add number labels to them, street addresses, as
I
it were, to
understand, I
distinguish. And
well, there's an easy way. And look, in the world of, it's not undoable. Like, for example, in physics project land, a good example, a good if wacky example, is we just got a self loop there to represent a different type of thing, right? That's a very pure graph type thing. Right? You can imagine there's nothing that says the rewrite rules can't apply around an annotation, which in this case is a very graph intrinsic annotation of a self loop.
Okay. Yeah. In fact, I had used self loops to label some of the atoms because they were special for what I was trying last year. That worked to a degree.
Right.
But annotations, I think, would go a very long way to let chemistry be represented this way.
Right. Well, I think that the general idea is we're not going to use pure graphs. We're going to use something closer to expressions. And that what we're going to have is a big expression rewriting thing. The issue is there's this trade-off because the graphs, the graphs connect things. Expressions have more structure, but it's always in a tree. And we just have to get the best of all those pieces. And that's why when next time we have one of these multi-computation discussions, it'd be good if people didn't say nothing, because we already know we've got targets like the theorem proving stuff, like the molecule stuff. We already know we've got to unify those things independent of all of the other stuff.
I think we were not in the last meeting. That's why we didn't say something.
Oh, well,
yeah.
That's
I can
a
imagine
problem.
myself not speaking up in a multi-computation meeting, though.
Yeah.
I have tunnel vision. I can work.
No, I'm not sure that you're the right person specifically for that meeting, but okay. So anything else we should particularly try and figure out with these reactions right now? I think the big thing is, okay, so what you're figuring out here is largely graph rewriting. Is that true? In other words, the question of, is it endothermic, is it exothermic? That is way out of band. Or is that not way out of band? Is that something you can compute given certain binding energies of molecules and things?
No, so our ability to do that rests at the moment with whatever thermodynamic data can handle. And so it's in the realm of the other, of chemical reaction instead of template reaction, that kind of thing. But even there, no, that's something we have to look up.
Yeah.
But in general, if I draw you an arbitrary reaction, do you have a fighting chance of saying what the energy absorption or release is?
Well, if we have the bond energies for the bonds that are broken and created, we can approximate it using that old method.
And
Well,
again, it would still be lookup individually for those,
Correct.
or trying to,
Yeah.
or some set of rules that you would use when certain bonds are combined together in a molecule.
And
Correct.
Bob and Jason, so this is not an application I've tried to do, but if you had a high level electronic structure theory and you had a unimolecular reaction, would it do you any good to compute the total energy of both states, or is that not a good representation of the reaction?
Are you trying to do a delta H of reaction at 0K and then work it up to G?
Yes, that's what I would assume.
Yeah, you pick your base set and theory level and do the calculation of all the reactants, all the products, and then go. Yeah, that's actually quite a good approximation.
And what happens at finite temperature?
So what do you mean?
So are
what
there
happens at finite?
corrections, or are there
Oh, at
finite temperature
Yeah,
corrections?
so if you go from 0K, then there's you have to have the second derivative so that you can do the vibrational corrections, and then you do the thermal corrections, and you approximate the when you go from enthalpy to enthalpy excuse me, from you go from enthalpy to free energy, you have to approximate the entropy. Usually use the ideal gas approximation.
And you also have to take into account the symmetry number based on the geometry too, I think, for the entropy.
Yep. Yeah, the entropy term often gets sloughed to one degree or another, depending on what your needs are.
Yeah.
Okay. Boy, so we might actually be able to do chemistry. It might just turn out to be graph rewriting. That would be, well, no, except the electronic structure calculations are not of that type.
Well, that's the hard part. We haven't got something that does that right now.
Right. Right. Yeah. Okay. All right. Well, so what is what? Okay. So we have questions about representing these reactions. We have partial answers to that. You know, I don't know whether the graph rewriting, it's probably the actual algorithmic graph rewriting for anything that is realistically chemically interesting. There's not a big algorithm problem there. Is that true? I mean, we're not dealing with complicated graph rewriting questions.
Right. I mean, so essentially, I mean, I don't know if this is what you mean, but I mean, what we do at the moment is we do the subgraph matching, and then we enumerate the matches, and then we do the stitching together to create the products. I mean, so the substructure replacement and keeping track of the atom mapping.
Right. I mean, I'm just wondering because we have pretty good technology for doing graph rewriting. I don't know whether we have to wheel it in for this case.
Well, what would be a complicated graph rewriting problem?
Hypergraph with 1 million nodes being rewritten with, you know, finding these particular subgraphs in it. I mean, generally, subgraph identification is an NP-complete problem.
Mm-hmm. And it is often hard for chemistry, but nowhere near like what you're facing with 1 million node hypergraph.
Right, where every node is the same. Whereas what you have is a bunch of, I mean, you might have a bunch of carbon atoms, but they're not, you're going to have a bunch of local structure, which allows you to dramatically prune the possible matches.
Yep.
Right.
Well, interesting. Okay, anything else we need to make sure to cover right now?
That's all I had.
Oh, there was a comment or question on our live stream from Fender. Can these quest reactions be run at different temperatures and pressures? Answer, not yet. Asking for a friend who wants to make a super hard diamond in the Jupiter atmosphere and return them to Earth. Boy, really? Why would it be a super hard diamond? Isn't a diamond a diamond? I thought it was just a carbon atom.
No, there's not this new pentadiamonds.
Oh,
Well, there
really?
are different carbon isotopes and that
Allotropes.
allotropes. I mean, yeah.
Well, I thought like graphite and diamond, but
Yes.
but you're saying, but Michael is saying there's a pentadiamond. What is
There's a
it?
pentadiamond that's, I think, the new super material.
Oh, really?
Conjectured, I believe.
It's conjectured.
I think it's only computed so far.
It's only computed.
Yeah,
Right,
that
but-
made
Wow.
it yet.
What?
You have to worry, be careful about these new allotropes, right? I once read a Kurt Vonnegut book, right, where the new allotrope.
Ice 9.
Right,
Yeah.
Ice 9.
I put in the chat.
Yeah. Was Claudio looking at that, Michael, last summer?
I don't
Also,
know. I do not know.
I think he's the one that tipped me off to that. And then,
Well, that's
then we
something
built
we
a
should
crystal
have for our
structure.
crystal structure.
Well, that's a hypothetical crystal structure.
I understand, but so what? It's I
Yeah.
mean, it's a useful crystal structure. We're not anything we're making in a computer is also hypothetical. I mean, it's a
Yeah.
Yeah.
but what is it in fact?
It's just a different carbon cage structure than the diamond.
But with different
cage structure.
hybridization of these carbon atoms somehow.
Right, so
Uh,
diamond
n-
is just tetrahedral carbon, right? I mean, it's just
SP3. SP3 hybridized, yes.
Yes, and I believe these are also. I'll dig up the stuff from last summer and send it to you, Stephen.
Okay.
No, the paper has been retracted. So take
Oh,
with
it
a grain of
has.
salt.
Interesting.
That's strange. Okay, because the likely because the energetics don't work out. Like you can't.
Oh, I didn't follow the story.
Bob, doesn't this remind you of Twistain?
Don't get me started on that. I spent a whole bunch of Christmas vacation trying to come up with that allotrope. And I still have the Drying models all tangled up on my desk.
Okay, fine.
Wait a minute. You mean physical models?
Yeah. I'm an
Yeah.
old-fashioned chemist.
You mean you actually have like one of these plastic chemistry construction set things?
Well, I had those. I've got metal ones. It's called a Drying molecular modeling kit. And
Yeah.
I'm the one that has the plastic ones.
Jason has the plastic ones. There are pictures of them in
models.
this blog or this presentation Jason gave last year.
Oh, okay. Interesting. Well, great. Okay. Well, I think it's probably enough for this. Yeah, Marco and live stream is commenting. Be nice to add crystal computation to Wolfram language. We have a bunch of stuff coming on that, right? Is Claudio still working on that?
No, he and I have not worked on it in close to a year.
Did it get to a point where it could be put in the function repository or not?
It's close.
There is also currently a really nice pack. I mean, so the package that Bob and Claudio were working on is great, but there is also one put out in the community called Max RD, or MA with a capital X RD, high targeted towards crystallographers that I really recommend.
Okay. Cool. Well, it is something we eventually should have in the system.
Yeah,
is
absolutely
crystal stuff.
Agreed.
All right. Well, good. Very nice. Lovely. Really.
Okay. Set for version 13.
I think so. Yep. Onward to reactions.
Yep.
After that. Okay. Thanks.